Okay, so we're getting ready to flash the firmware on the APS 2.8, the Pilot. And there's a few things that are a few modifications that we're making here. And because I've checked some stuff on the internet, and what they're showing me is this right here is a power module. Okay, so it's a little electronic circuit board that's tied into the plane here, and the battery plugs straight into here. Goes through the modular circuit board to the back plane, powering all the motors and all the ESCs and stuff here. And it's also got a lead that pops loose and comes around and is somewhere I can't find at the moment. Here it is, right here. And we'll plug it into the PM port on the Pilot. And that is the power port. And so this will supply power to this flight controller. You have a JP1 jumper here. And that JP1 jumper is, by default, was installed on mine. So barring dropping your jumpers all over the place and finding them. Here we go. I took it off, and this is why. So my understanding, that jumper connects the circuit board in here. Each one of your ESCs here, which come off your main board, is capable of powering this module. And so if you have the red wire from any of your ESCs connected to this module, then that's powering it. Now, if you're powering it here and you take here and you're powering it into here, that is the equivalent of taking an extension cord with a plug on each end and plugging them both into the same outlet. They will get really hot really fast. There will be a loud pop and you'll wake up across the floor if you wake up. So that's kind of what happens here, but only the magic smoke comes out. So I thought about it, and the guy that was talking about this made a lot of sense, and so I decided to do the same thing. So if you're powering through your ESCs on your output side right here, then you have the potential of these motors, you taking and doing some heavy maneuvering and drawing the amperage and or voltage down from the battery supply, can potentially messing this up, kind of like a brownout. So a brownout is where your lights go dim and then come back up again. And sometimes it causes your TV to reset, sometimes it doesn't. Well, that's the same thing here. It may reset this whole module and mess things up in the middle of a flight when you're doing a heavy maneuver and you draw the voltage down on the battery, which comes right back up again as soon as you're done with the heavy maneuver that these motors are pulling from the battery. So in this particular case, you're not pulling straight from the ESCs here supplying voltage. You're supplying voltage in here, and I've just got one connected. I pulled the red wires out of each one except for one. I left one connected in because I'm not really sure if it would be smart to have all of your drone ESCs going in there. So basically number 4, which here, this one, is the only one supplying voltage into this side of it. So I pulled the jumper off because I'm also going to use this to supply voltage to to power it as well, to power the controller. So that's coming off of the, I guess it would be probably a step down voltage regulator. And so the thing about a voltage regulator, it requires X amount of voltage in, and it continuously supplies an output voltage that it can maintain. And it can take a lot more voltage drop and such as that than just a straight connection that you would be running otherwise. So it made a whole lot of sense to do that. So to keep my ESCs from deadheading against my power supply coming off of my, I guess it would be a buck voltage regulator off of this power module supplied in here. So I should have a good, steady, solid power supply to the flight controller, and also I'm supplying the voltage through one of the ESCs over here on the outputs. I don't fully understand what that exactly is over here. I guess normally it would expect you to pull all of them, and with the jumper in, then the voltage would be supplied back through here as well if you clipped all of your red leads on your ESCs. And so your voltage would be supplied through here. And you would still cause a drain on heavy maneuvers through the circuit board itself. I think it's just less strain when you are pulling your voltage from your ESCs through one of your ESCs on this end, and then your power module is supplying voltage to the board to function through its normal power support. So I pulled the JP1. Long-winded way of saying I pulled the JP1 to keep from destroying this thing and left one ESC red wire connected. Now I'm not clipping these off. I just pulled the little clip up and pulled the ends out. I'm going to take and either put heat shrink on these, or I am going to maybe tape them temporarily, but I will secure them because I may change my mind. I do that a lot. So I will secure these so that they're not going to short out or anything like that. But at worst case scenario, I may just double them back, put a piece of tape on them, and just slap a tie wrap on there, a little tiny tie wrap, and call it good. I don't know. But I do have number 4 motor is still connected in. That's the only one that's got the red lead still connected. So there's another modification. And this kind of helps you because I'm using a FlySky receiver. And I'm going to be trying some other ones too. But if you look on the FlySky receiver, you'll see S plus minus. And so the connector is vertical here. So orange is S, red in the middle is plus, and brown is negative. And if you look up here on this, coming straight into here, we're going to pull this top off, and you'll see, hopefully, the same thing. You've got S right here coming onto the top lead with orange. You got plus in the center coming through to red, and negative at the bottom coming straight across to brown. So maybe that'll help you as it does me to have that visual to see how it's running across there. You also, I think maybe it's older ones, maybe it's newer ones, maybe I don't know. All I know is there's other ones that have jumpers sticking up here with a jumper on this connector right here. And it is my understanding that if you leave the jumper, if you jump these two right here, even if you have a jumper to put on it or however, then you would be using this board's internal compass. Well, I have the GPS here, and it's got a compass built in, and that's what I'm going to use. So for that to be active, you have to pull that jumper, which it didn't have a jumper, so I'm just leaving it as is. But then this is where the JP1 jumper goes, is right across here. And with these shorted, it connects the outputs with the rest of the board to supply the board voltage. With that pulled off, you cannot supply this board with voltage through these pins. It has to be through this port off of that power module. Now, what we are actually doing here is there's another modification that we're going to make. So if you'll look, you have right here, which is this one, is the I2C. Right here you got the power and the I2C port. That's this power, and this is the I2C port. Well, I mean, an I2C port you can take and in electronics, I don't know if on this, but in electronics, you can power a LCD screen. You can do graphics across it, hook up, make it like a tiny monitor, all kind of things. There's tons of things you can do. And I don't see why you wouldn't be able to actually create a graphical interface, or at least a graphical output, to give you basic information, potentially battery condition or whatever, and put that information on an LCD screen through here. So I want this to be free. So I don't want to plug my GPS in here and in the I2C port. And that's what you, by default, would have to do. So I want to use this port right here. So my GPS will be plugged in the top, and the other one will plug in here, which is the only other place that the plug will fit. And so to do that, and actually to enable this here I2C port, there's a little bit of soldering that's got to be done, and that is over on the bottom side of the board. And so let's see, I don't know if I can even zoom in close enough to see it, but you've got OSD, what is that, JSDJ or JDS external, OXRA DE or SDV. I'm sorry, I'm reading this upside down, backwards, and sideways. I don't know. I really can't just get my eyeballs. I keep forgetting my eyeballs. It's almost like that is written backwards and upside down while I'm looking at it upside down and backwards. So it looks like I've got RA2 SDA RXO TXS SCR and OSD on these jumpers. It's like their screen printing was backwards or something. So I need to jump or create a solder bridge on the OSD, and I'll have to check and see what the other jumper is. But the OSD jumper is what will enable the I2C port. And okay, hold on just a minute. I'll be right back. Okay, sorry about that. So anyway, like I was saying, where is my solder? I'm running out of my little ball of solder. I have to go find my good roll of solder. So like I was saying, you have to bridge two connections here. You've got the RXO will bridge that connection, and the DSO connection to enable the I2C port and to allow OSD to hook a camera through the I2C port. So if you hook this up, like a lot of things say, to the I2C port and it doesn't work, you need to bridge these pads and it should work. Otherwise, you'll hook the GPS to here and this port right here. If you want to use this port, you got to do what we're fixing to do. So let's see about get this heated up. And I always have problems bridging pads for some reason. And I think I did it. I did it again. Come on. We are cooking. There we go. So the OSD, which is the top one up here, and the bottom section where you have 3 more connections. The top one on that, which is RXO, are now bridged together. So the I2C port should be active, and this is no clean flux, so I shouldn't have to clean anything on it. Should be good to go, and I'm not going to clean it because I ain't supposed to have to clean it. So there. So we got those two bridged. Pretty nice, pretty good. And all I can tell you about bridging little tiny pads like that, I mean, they're about the size of the head of a pin. So about bridging those little tiny ports is to try to get solder on your gun and just wiggle it back and forth to each one of the pads. And when you see that you've got solder that's stuck to each of those pads, then kind of brush across the top. And then it should mesh together and you'll have it bridged at that point. You got to be careful that you don't burn the pads off the circuit board, which you can do if you're not careful. I'll be right back. Okay, sorry. My wife rudely interrupted. Not rudely. She knocks now because she don't want to be on video. Anyway, so just kind of brush across the top real quick. And hopefully that'll make you a nice solder ball. Because the way a circuit board is, everything in between the silver pads is designed to not allow solder to stick. And that's why a lot of times it's hard to bridge 2 connections to begin with. Now, if you don't want to bridge a connection, you can do it every time. But if you want to bridge a connection, I have trouble every time. Except for this time. I don't know. Go figure. So now my I2C port should be active and functioning with those 2 pins bridged. And I'm going to hook my GPS over here so I can still have my I2C port available. And I'm hoping that that may make it a little easier for me to go with the camera setting up. So I pause it on the other side and you should be able to find a good spot to really zoom in on the circuit board. I'm going to try and find a spot to where I can zoom into it and get as close, maybe make the circuit board fill the screen as much as possible, and that way you can pause on that side to see the details on the circuit board. And let me try to reposition this in just for a second. And hopefully I've got that pretty well squared on the screen that I can zoom in here and cover the top side of this circuit board so that you can see all the details on it. This may be a newer version, I don't know, but it doesn't have the pins soldered into this header right here. This header, I'm not showing anything there. Look, you got ground in the upper right and then 5 more pins. I don't even know what that is. I don't know if maybe that's a potential expansion for some more little Molex type. I don't know if that's Molex or what, but those connections there. So anyway, and hopefully you see how the writing is backwards and upside down, and that is not my camera messing with your mind. That is the world messing with mine. So anyway, there we have that. So now that I've got that modification done, I'm going to pop the top back on. Whoa, hold on. Put our little sponge pad back in there. I don't know why that was there, but it's there, and I'm putting it back. So we got that down in place. So I'm going to reinstall the top. I'm not gonna make you watch it. I'm gonna cut away, and when I come back, we're going to. I'm not sure how I want to do it. I may do a cutaway to where I record my computer screen so you can see me download the firmware to flash this with, and then I'll show you the process, maybe in a picture-in-picture or something. I don't know how I'm gonna do it, but I'll do that. But that will, when I come back again, that's what we will be doing. So we'll be right back. Your time is very important to me, and I thank you for spending it here with me. Thanks, and God bless.